petroleum diesel spills in Bellingham, Washington, with the Department of Transportation. And I worked with Battelle Laboratories for 4 or 5 years. And we introduced oyster mushroom mycelium into a mound of petroleum-contaminated soil. It had 2% of what's called PAHs, polycyclic aromatic hydrocarbons. And the PAHs were reduced from 20,000 parts per million to less than 200 in 8 weeks. And this was an astonishing success. No other treatment using biological systems worked this fast. Our pile started fruiting with oyster mushrooms prolifically, hundreds of mushrooms. And this is all featured in my books, and the mushrooms are perfectly edible, and it detoxified the substrate. So microremediation has really surged in the past few years and has gone through a rebirth in the past 2 to 3 years. And there are several groups now around the world actively using microremediation strategies to break down toxic waste in their ecosystem. So I would really encourage people to I'm unabashed about this because this is the first book that I wrote. I've got 6 books out. This is the first book that I wrote that I was so anxious to get it done. I was so concerned that I either have a heart attack, I have a car accident, I would die before the book came out. Because the book is more important than the author that wrote it. The book is indeed something that can help humanity. And I think this book will carry on through many lifetimes because it shows people the way of using mycelium to help the ecosystem and ultimately help ourselves.
Now, you've also touched on the theme of producing biofuels with mushrooms. Could you talk about this?
Yes. It's a very sensitive subject because the IP is extremely hot. But for 30 years, I've been digesting cellulose with mycelium. The mycelium digests the cellulose and produces fungal carbohydrates, sugars. Carbohydrates are polysaccharides, more than one sugar joined together. And yeast and bacteria can break down these sugars to generate ethanol and other types of alcohol. So I was looking somewhat perplexed at the literature where they were concentrating on Aspergillus oryzae, which is used to make sake and other types of wines, and the Saccharomyces cerevisiae, which all enjoy that. Many of us do, in beer, etc. And there was a form of biological racism against mushrooms. And given that the largest organism in the world is the mycelial mat of a mushroom, and I have many years of experience in running mycelium on various types of cellulosic substrates, straw, wood chips, paper, etc. I knew I had a big advantage in my knowledge, and so I tried something that was intuitive to me but non-obvious to other people, and so far the results show a significant enhancement of ethanol fuel production over that of pre-existing technologies. So I filed a patent on that in September, and we are actively involved in research even today. It's a daily project here of enhancing ethanol production using the enzymes and the mycelial mats of selected fungal species. And I'm not really prepared to talk about it much more than this right now, for a lot of really good reasons, not just because it's sensitive intellectual property, also because the data fields are not quite complete, but that which we have seen so far gives us a strong encouragement. I'm not hip on cutting down the forest, folks, to make biofuel. I think it's a really bad idea, and I don't like the idea of using corn, to generate biofuels, because I think corn as a feedstock for animals is a well laid down path. But looking at other waste streams that are not presently being utilized that can still help build soil, and I think that is the best of the available substrate streams that we have not currently utilized. And so I like the idea of using cereal straws and growing these fungi on other waste products that will not threaten pre-existing food chains that have already been well established.
Speaking of patents, you have been recently granted a patent on a natural method for for the control of social insects in the order Hymenoptera. Could you tell us a little bit about this?
Yeah, people, patents are to serve the public interest and to reward the inventor for 17 years. And I am sort of mycocentric in my point of view, and that's been to my advantage, obviously, because, again, speaking of mycophobia, the pesticide industry has invested up to $100 million in biopesticides using entomopathogenic fungi. These are fungi that infect insects, and actually some of them are used medicinally. One is called cordyceps. Cordyceps sinensis, dongchong chichao, is a well-known medicinal mushroom in Asia and been used for thousands of years in tea to improve stamina and athletic performance. It has an anamorph, which means there's like two sides of the same coin. A fungus can have two expressions, one in a mushroom state, one in a mold state. Well, the mold state is of the cordyceps. One of them is called Metarhizium, also pronounced Metarhizium. And Metarhizium is a green mold similar to the Penicillium molds. And lots of patents have been issued, lots of great scientists, people far more skilled in the subject than me, have done great work over 20 years, and they enhance spore production and the virulence of spores, so less spores would have to be used per acre, and they could treat, bull weevils and other type of agricultural pests besides urban pests such as termites and carpenter ants. But then they created these experiments where they would brush the insects with a brush that had spores on it, and the spores would infect the insect and kill them. That would usually happen within a week or so. Now, social insects have a queen, and the queen is guarded and protected at all costs. So there are guards at the entrance to the colonies. And if one of these workers that come back from foraging has spores of Metarhizium, they won't let that worker into the nest. And so the guards actually will capture one of these infected workers. They're constantly trying to groom themselves, but the spores become embedded. And if the spores are embedded, they can't get them off. And so the guards will pick up the workers and take them to a graveyard, literally a graveyard, and they decapitate them, and they kill the worker, but then the guards remain in the graveyard because they've been exposed. And the graveyard is the source of where these strains are. So I can get these strains, or anyone can get these strains out of a graveyard from a termite or carpenter colony, because they all have them, and they keep the graveyard separate from the mother colony. So there's a very strong aversion to the scent or smell of these spores. The insects have learned that these are pathogens. So the scientists, even though they demonstrated this in the laboratory by directly applying the spores, couldn't get the insects to come to bait stations when they were put outside around buildings, because the insects aren't stupid. They could smell the plague when they got near it, and they turn around and run away. And so the use of these spores for preventing termites from destroying your house, it was never successfully commercialized. So I had a very funky house, and that was built in 1910 and then rebuilt in 1965. It was a flat roof in Washington State. Makes no sense at all. I had 12 buckets catching water through the roof. My wife one day during a storm, the house shifted and the roof partially fell down 4 or 5 inches. And she said, "Oh my gosh, the house is falling down." And I said, "Don't worry, dear. The roof is no longer flat. That means the water will flow off the roof faster. We don't have to empty the buckets as much." It's a really unusual setting for me, but maybe great for my mycologists because there's so many molds and insects all around me. But I went on the EPA.gov homepage and I discovered that Metarhizium was being favored because it does not kill bees. Actually, they are doing experiments now using bees as carrier pigeons for Metarhizium, so it can kill the varroa mites that are killing the bees. And so it's bee friendly. So the EPA likes this group and is encouraging research. I ordered some of these cultures, and I'm not an expert in Metarhizium, and I got these cultures, and they're like Penicillium molds. There are mold spores everywhere, and the last thing I want to have is free-flowing spores flying throughout my laboratory. So I took some of these cultures, and I quickly plated them out. That means I put them on to Petri dishes, and I did this as quickly as I could. And I was saying, this is going to be a big problem for me because I have spore-free clean room environments, and I didn't have a biohazard at that time. And then I saw a little wedge of white mycelium. that formed, as a V-shaped sector on the petri dish. And it's just a white growth as opposed to a green growth. And so I thought, oh, that's interesting. I looked up in literature, and everybody in literature said the sectoring of Metarhizium is bad. Fewer spores, fewer missiles, less potential of death. And I thought, well, I'm going to chase this sector of white mycelium. So I did that over several weeks, and I transformed the culture from a green mold penicillium-like culture into one that's white and fuzzy that had no spores. And I delayed sporulation. And then I made my daughter, who was living with me, she was 16 at the time, and I made a big scene that we're going to trick the carpenter ants. And so every time that I was vacuuming in the morning, this big pile of sawdust in one part of the house would gather, and I'd vacuum it up, and now the carpenter ants were, at work again last night, and they'd eat part of my house, and they'd be on the floor the next morning. And so I knew there was a point of entry, and I could see the piles of sawdust and carpenter ants once in a while going through this one point. So I went to my daughter, and I asked her for a little Barbie doll dish. So I put down mycelium that grew on rice without any spores of Metarhizium onto the dish, and I put it down, and I made a big scene with my daughter and my wife saying, we're going to trick the carpenter ants. And then we put it down around 9 o'clock at night in the summertime. And then my daughter, around midnight, had to use the bathroom. And she thought, when she got up, well, I might as well look in that dish. And she walked by it, and it was swarming with carpenter ants. And she woke us up, said, Dad, Dusty, come and see this. You got to see this. And we woke up, and we saw the carpenter ants pick up the mycelium on rice and march it back into the house. Well, 1 week later, there's no sawdust piles. Now, hadn't she seen that, mice could have eaten the rice. I would have known. But I was able to get rid of carpenter ants in my house, and they didn't come back. For 5 years, we had the house longer until it was torn down. But the carpenter ants never reinvaded, probably because after the end, it was queen friendly. It was given to we know from experiments now, it's given to the queen distributes it. The workers become like little mushroom growers again, and the entire colony is infected. And before they know it, they've spread this infection throughout the entire colony. So I talked to a friend of mine who's a patent attorney, and I told him I'd looked in the literature, and everyone said these sectors were bad, and I delayed sporulation. I think I found something that's very clever. And so he agreed and did some more work, and so began filing patents. And my second patent was issued October 17, 2006. That's viewable on the USPTO .gov homepage. That's U.S. Patent and Trademark Office homepage. The second patent is what's been called the Alexander Graham Bell patent. It could literally replace most chemical pesticides in the world with a very inexpensive solution that's environmentally sound. And I realized this discovery has huge responsibility. And so I created the guiding principles that are attached to my patents. And the number one guiding principle is we wage no war against insects. We want to preserve insect biodiversity. I just don't want termites eating my house. And so I have a series of very strong ethical and ecological statutes that are the guiding principles of my patents. So this patent has been awarded against all social insects, more than 200,000 species, using Metarhizium, Anisoplium, and Beauveria bassiana. That's a white mold. That's the anamorph of cordyceps. So cordyceps, the mushroom, can have more than one other form. And so this patent is considered to be a huge breakthrough, and ultimately my goal would be to go to Africa, and I think I can steer a locust plague into a 55-gallon drum, or more than one, because they produce these very strong aromatic yet unknown compounds that steer insect invasions. And so we've treated this against fire ants, carpenter ants, subterranean termites, formosan termites. I've now tried it against non-social insects with great results. So now I'm pursuing patents that'll give me non-social insects. If that happens, then I'll have the entire kingdom. This is so significant. It's probably one of the most significant scientific discoveries, I think, in the field of mycology ever made. I'm somewhat surprised that I made it because a lot of other smarter people than me that have been working on this, but they, again, could not have seen the forest for the trees, perhaps. And I, being independent, just thought a little bit differently. We've engaged the pesticide industry for the past 4 years. They did experiments that actually were better than ours in terms of the results. And unfortunately, I've come to the sad realization, which I had at the beginning, but I sort of forgave these pesticide companies temporarily to see if they really truly wanted to become green. But logically, these companies that have billion-dollar profit wheels based on the petrochemical of what's called PAHs, polycyclic aromatic hydrocarbons. And the PAHs were reduced from 20,000 parts per million to less than 200 in 8 weeks. And this was an astonishing success. No other treatment using biological systems worked this fast. Our petroleum diesel spills in Bellingham, Washington, with the Department of Transportation. And I worked with Battelle Laboratories for 4 or 5 years. And we introduced oyster mushroom mycelium into a mound of petroleum-contaminated soil, had 2%. And there are several groups now around the world actively using microremediation strategies to break down toxic waste in their ecosystem. So I would really encourage people to I'm unabashed about this because this is a file started fruiting with oyster mushrooms prolifically, hundreds of mushrooms. And this is all featured in my books, and the mushrooms are perfectly edible and detoxified the substrate. So microremediation has really surged in the past few years and has gone through a rebirth in the past 2 to 3 years. First book that I wrote, I have 6 books out. This is the first book that I wrote that I was so anxious to get it done. I was so concerned that I'd either have a heart attack, I'd have a car accident, I would die before the book came out. Because the book is more important than the author that wrote it.